So what I wanted to speak about today specifically was sigma notation, because I know that this is something that often throws us. And when we see the sigma symbol, which I've written here in green, what is that an instruction to do? When we see this funny E-shaped thing, what are they telling us we need to do? What does it mean to us? What does this symbol represent? Matrix? What does the sigma symbol mean? You can pop it in the chat. You don't, if you're feeling shy and you don't want to talk, that's okay. What does it mean? There we go. Exactly. So in other words, it means sum. Quite right, Nolwazi. All right. And the word sum means the sum of, means that we are getting an answer when we have added things together. Okay. So there are two sum formulae that we learn about in matric. Either our arithmetic sum formula or our geometric sum formula. So when we are working with sigma notation, we need to decide whether it's going to be an arithmetic sum or whether it's going to be a geometric sum. But before we get started on that, and I know I've had this discussion with you before, right? But very, very important. When we are working with sigma notation, we have a number at the bottom and we have a number at the top. So now let's pretend the number at the top is 9, and let's pretend n is equal to 2, and let's pretend here my roll is 2n plus 1. Okay. What does the number at the bottom represent? When they're telling you n equals 2, what does that mean for you, matrix? Okay, am I clear? Mm-hmm. Who's talking?
Ma'am, it's Linda.
Okay, Linda. What does the number at the bottom represent?
Ma'am, isn't it this? Don't use n as a substitution to determine the value of the first term.
Just say that again. Don't you use
n to determine the value of the first term?
Absolutely. Okay, so when you say n equals 2, or I say n equals 2 at the bottom, that is the first number you are going to sub into your rule. Okay, it's how we would calculate our first term. The first term is not 2. Okay, but we are going to use n equals 2 to calculate our first term. Okay, so at the bottom, n equals 2, this is where we begin subbing into our rule. Okay, so this is where we begin subbing in. The number at the top, what does that represent? What does the number at the top represent? And again, if you're feeling shy, you can put it into the chat. What does the number at the top represent, Matrix? Let's see what you guys are saying. Okay. All right. I'm so glad that you are saying this. The number of terms, the number of terms, the number of terms, the number of terms. Okay, Teddy has said something different. The last number to be subbed in, the number of terms. Ntlantla. Okay, so only Teddy and Ntlantla have got my last question correct. Okay, everybody else is wrong. Okay, there are not 9 terms in this pattern. The number at the top is not the number of terms in the pattern. Okay, it is the last number to be subbed in. Now, I'm asking you this because I figured that you might fall into my trap. So I think what I need to do, correct in Klantla, number at the top minus the number at the bottom plus 1. There would be 8 terms in this pattern. But I think what would be good here is for me to show you why the number at the top is not the number of terms in the pattern. So Teddy and Nhlanhla, my apologies that you guys know this, but just give me a second. I'm going to try and explain this to the others. And hopefully this is going to be one misconception that we can clear up fairly easily. Okay, so let's use a different example matrix. Let's pretend again that we are subbing in at n equals 2. And let's say this over here, I'm going to change that to 4. And let's keep this rule simple. Let's make it 2n plus 2. Okay. Now, if you are telling me this is the number of terms, you are saying potentially that there are 4 terms in this series. Okay, have a look at this. In order to create the first term of the series, we have to sub 2 into the rule. Maybe using, hang on a second. Let's use other numbers. Let's make our rule 3n plus 1. So our first term is going to be 3 times 2 plus 1. That's our first term. Our next term, we're going to sub 2 in. Sorry, we sub 2 in. We're going to sub 3 in. So this is going to be 3 times 4. Ah, man, I'm talking nonsense. Beg your pardon. 3 times 3 is the next number up. Plus 1. Okay, next number would be 4. So this would be 3 times 4 plus 1. Okay. Are there 4 terms in the pattern? There's 3 terms in the pattern. Here's the first term, here's the second term, here's the third term. The number at the bottom is the first number to be subbed in. The number at the top is the last number to be subbed in. Okay, there are 3 terms in this pattern. That's why we say when we're working with sigma notation, we calculate the value of n by taking the number at the top, minusing the number at the bottom, like Nhlanhla put onto the chat for us, and then we add 1. Can you see there are 3 terms in this pattern? Okay, the number at the top represents the last value to be subbed in. Okay, it is not the number of terms in the pattern. Does that make sense to everybody? Can you see that now? Okay, so Letabo, Nowazi, Guguletu, Mamelo, Daka, Amatle, you were the ones that were brave enough to say something. You don't understand when you say it's the last number to be subbed in. Okay, so in other words, to create the terms in our pattern, 4 is the last number that got subbed into the rule over here, that 4 over there. It's the last number to be subbed in to create the last term of the pattern. That's what I mean. When you sub in 4, that is the last term of the pattern. Does that make more sense to you now? Teriso? Okay. Okay. Now hang on a second. Lebogang, what do you mean 5, 7, 9, 11, 13? Are you talking about the terms in the pattern? Because here the first term here would be 7. The second term would be 10. The third term in this case would be 13. Okay, so in this particular pattern over here, there are only 3 terms. Are you talking about the previous one or this particular pattern? Previous one. Okay, well, we'll go back to that now and go and have a look. All right. If you start subbing in at 1, okay, so now let's just have a look at that quickly before we move on and go back and look at the previous question. Okay, so let's just change this. Okay. What I'm going to do is I'm going to stick with the same example. Now let's pretend I started subbing in at 1. Okay, so let's just change this. We're going to keep the same number at the top just to make life easier. Okay, so now we would create the first term by subbing in 1. We would create the second term of the series by subbing in 2. We would create the third term of the series by subbing in 3. And we would create the last term of the pattern by subbing in 4. Now there are 4 terms in the pattern. So if the number at the top, if you want that to be the number of terms in the pattern, you would need to start subbing in at 1. But you don't always start subbing in at 1. Okay, so you cannot just assume that the number at the top is the number of terms in the series. Okay, if you start subbing in at 1, then it will be, because the number at the top minus the number at the bottom plus 1 is still going to be 4. Okay, but it's not always the case. So let's go back and go and have a look at this particular example over here. Are there 9 terms? I'm talking about the one in the middle now that we were talking about in the beginning. Are there 9 terms in the pattern? Are there 9 terms in the pattern? No. Good. Okay, there are not 9 terms in the pattern. And if we subbed in 2, so just count on your fingers. Just count on your fingers, guys. You're going to begin by subbing in 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. How many fingers are you holding up? 8 fingers, right? Okay, I don't know if you're doing that at home, but anyway, there we go. So you start subbing in at 2, 3, 4, 5, 6, 7, 8, 9. You're holding up 8 fingers. There are 8 terms in the pattern. And that's why we say here in orange, how do we calculate n when working with sigma notation? Irrespective of whether it's an arithmetic sum or a geometric sum, you always calculate the number of terms. Sorry, my brain is on holiday. The number of terms in sigma notation is always the same. Okay, it is the number at the top minus the number at the bottom plus 1. And this becomes especially useful for us. I mean, if they give you like 100 at the top or 200 at the top, you're not going to want, you don't have time to go and sub in each one of those numbers starting at 2 all the way up to 100 to work out the value of each term. It's not necessary for us to do that. Okay, so we can use this quick and easy way of being able to do it. The number at the top minus the number at the bottom plus 1 will always give us the number of terms in that particular series. Okay, so there's 8. That's right, Lebogang. There's 8 terms because you say the number at the top minus the number at the bottom plus 1. Beautiful. Okay, so when we are working with sigma notation and they tell you to calculate or evaluate, that's basically a fancy way for saying calculate the sum of, right? So what you would do is you'd sub in and you would generate, say, the first 3 and the last term of the pattern. So you'd sub in, and here you'd end up with the first term being 2 times 2 plus 1. And then the second term of the pattern would be 2 times 3 plus 1. And I'm just going to scooch over a little bit here. Sorry, this is just where we were writing earlier. And let's say the third term of the pattern, so that would be 2 times 2's gone in, 3's gone in, 4's gone in, plus 1, plus da 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 da. The last term of the pattern would be 2 times 9 plus 1. Okay, so we always begin by subbing in. So the first one was 5. The next one was 7. I don't know if it was you and Martley, you were saying this to us. 9 plus, and then the very last term in the pattern is going to be the number 19. So if we have a look at the terms of our series, we can see that there is a constant difference. Okay, also we need the value of A, the first term of the pattern. So after you have subbed in, you then need to write down what is the value of A, and in this case, what is the value of D. So the value of A is what matrix? Lovely. The value of A is 5, the first term of this pattern. What is the value of D? Yes, A is 5 and D is 2. There is a constant difference. All right, so that means that we can use, if there is a constant difference and not a constant ratio, it means that we need to use the arithmetic sum formula. You've also worked out the value of n. You've told me this already, that it's 8. 9 minus 2 plus 1 is 8. So straight away, what I can do is I can calculate the sum to 8. Okay, so if you remember the formula, it's n over 2, 8 over 2, and then in here it's 2a plus n minus 1 times d, which is 2. The formula is here on the left-hand side. You don't have to write the formula down first, but you've got to show that you subbed into it. So it's this formula over here that I was using. Let's just put it over there for you. Okay, Amahle says the sum is 124. And Hlantle, you're getting 96. You're getting a different answer to Amahle? What are the rest of you getting? I'm also getting 96. Amahle, just check your... Okay, that's okay. Sissy Paul? Okay, hang on. Okay, hang on. Let's just go back. All right, so there's a few questions here. All right, first of all, let's just write down the answer, which is 96, and then I can answer your questions. All right, so it's okay, Amahle. Okay, so let's just go back here. Okay, so Lorraine, I hope I'm pronouncing your name correctly today. What is the difference between arithmetic and linear number patterns? Absolutely nothing, Lorraine. When you were in grade 8, grade 9, grade 10, and grade 11, pretty much, they referred to them as linear number patterns. And for some reason, I don't know why, in matric, we call them arithmetic and geometric, but there is no difference at all. So an arithmetic pattern is a linear pattern, one with a constant difference. Okay, so that's answering your question. Sissy Paul, you are talking about that formula Sn equals n over 2, and then it's 2, is it 2a plus l? Oh, I'm just trying to remember if that was correct. Good. Okay. So you can use this formula as well. Just give me 1 second. I just want to double check myself because I'm not very good at remembering formulae. I must be, or not ones that I don't use on a regular basis. I don't ever really use this formula. And not that there's anything wrong with it, but I just don't use it on a regular basis. So I just want to double.
You guys are doing really well, though. You're doing amazingly. Amazing well. Palesa, you and I both, we are both on
Give
load
me a
shedding,
second,
girl.
guys.
No worries, Teacher Lee.
You shouldn't, that being said, you shouldn't ever need to use that formula. It doesn't, there would never be a situation in a matric exam where you could only use that formula and not the other one. Where it comes from is A plus, I'm just checking myself because A plus n minus 1 times d is the nth term. That is the last term. That is L. And then they add it to A. So I think it is 2A plus L. But anyway, never mind. It's okay. Jethro, leave it. It's fine. But you can use
Ma'am?
that formula. Yes. I think it's A plus L. N over 2A plus L. There we go. Okay, it doesn't have the 2 in it. There we go. All right. Yes, because as I was saying, A plus N minus 1D is already L. So yes, A plus L. That's it. It's not 2A plus L. Perfect. So yes, Sisipo, if you do want to use this and you know the last term in the pattern, absolutely nothing wrong with it. You'd still get all the marks. Absolutely. It'll still give you the same answers. Okay, so the example that I did with you now was with an arithmetic sum. I also want to talk to you about sigma notation being used for a geometric sum. Okay, so let's go back and go and have a look at this example over here. All right, so they've asked us to calculate the sum of, and the way that we would actually read these. So for example, if I take this one over here, if I was to read that out, this is what you would say, right? Calculate the sum from m equals 2 to 100 of 7 minus 2m. Okay, that's how you would actually read it. Calculate the sum from m equals 2 to 100 of 7 minus 2m. So this one over here, we're calculating the sum of from I equals 0 to 19 of 3 times negative 2 to the I minus 1. Okay, so this is an instruction to calculate the sum of a series. Okay, using our geometric formula. But now let's pretend that we didn't know that it was geometric, right? How would we know that it was geometric? Well, we would have to begin by subbing in and generating the first 3 terms of the pattern. Okay, so that would give us an idea as to whether there was a difference or whether there was a constant ratio. Okay, so let's begin by subbing in. The first number that we're going to sub in is what, Matrix? What's the first number we are subbing in? 0. Beautiful. So I'm just going to do this a couple times. And for argument's sake, we could also create the last term in this pattern, and that would be created by subbing in 19. Okay, so the value of A, the first term, is what in this case, Matrix?
Minus 3/2.
Minus 3/2, says Linda. Do the rest of you agree? Good. Thank you, Linda. So 3/3/2. Hang on, must be minus 3/2. Yes, sorry, quite right. Minus 3/2. Okay, the next term is, yes, minus. The next term is 3, agreed. The next term is, it's -6. Okay, so can you see in this particular pattern, our signs are alternating. Negative, positive, negative, positive, negative, positive. So it doesn't matter. All right, it's still seen as a sum, even though some of them are negative. All right, we're still adding the terms together. Essentially, we're just adding negatives, which means we are subtracting. If we wanted to, we could work out the value of the last term. We don't have to, but we can just go ahead and go and do that anyway. What do you guys get as the value of the last term? That is a big number. Yes, I'm getting the same thing. So 7, 8, 6, 4, 3, 2. All right, so when we look at these numbers, we can clearly see there is not a constant difference. All right, how are we going to work out the value of R, the constant ratio? What do we do to calculate R? Thank you. How do we calculate R? Do you guys remember? The second term divided by the first term, fine, or the third term divided by the second term. Cool, that's also okay. Yes, all of those suggestions are absolutely fine. Okay, so you're going to divide a subsequent term with the previous term. All right, so what is the value of R in this case, guys? What are you getting? Indeed. Okay. I quite agree. And the value of A? The value of A is? That's it, Nolwazi and everyone else. Good. And now N. How are we going to work out the value of N? Are there 19 terms in this pattern? I hope you're all saying no, 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 no. Good, Mamelo. Okay. No, there's 20. Good. Well done. So the number at the top minus the number at the bottom plus 1. Good. Lovely. Well done. So now we have established what A is, what R is, and the number of terms in the pattern. So now we can go and sub straight into our geometric sum, which is this guy over here. All right, so we can sub straight into that. And again, what we can do is we can say sum to 20, because we know there are 20 terms. We know the first term is minus 3/2. We know the value of R is -2. Remember, you must put R in brackets. We know that N is equal to 20 minus 1 over R minus 1. Okay, it's very, very important in this bit over here, matrix. You must use brackets when you sub in R. Okay, because depending on whether your exponent is an even or an odd number is going to affect the sign of your answer. Okay, so you must put R in brackets. Okay, so I see there's a few others with hands up, so I hope I didn't make a mistake. Let's see. Okay, so Linda, you were first. Go for it, Linda. Linda, you're welcome to unmute.
Ma'am, for the
Hmm.
number pattern, isn't the last term negative?
Okay, let's just double check. I don't think it's going to be negative. Why do you think it's negative? Why do you think it's negative, Linda?
Calculator
Are you
says
using
so.
brackets? Are you using brackets around the -2?
It says negative.
Okay, is anybody else getting a negative at the end there? Because I'm not. Thanks, Pamela. Anybody else getting a negative here? Because I'm getting a positive. No. Okay. So, Linda, just to answer your question, what you were asking about is actually what I was trying to say when I was talking about putting this -2 that I've highlighted in pink. Okay. Linda, look at this. If you say -2 and you put it in brackets and you raise it to the power of an even number, you're going to get a positive outcome because a negative times a negative times a negative times a negative is a positive. Okay, if you say -2 and you put it to the power of 4 like that, then you're going to end up with a negative outcome. So if you have got +3 times -2 to the power of 18, because this number is even, this value has to be positive. Okay. All right. Now, again, you've got to be super careful about how you put this into your calculators. You've got to make sure that that -3/2 is in the numerator. Okay, I'm just also going to work out the answer here, although a lot of you have already done that. Okay. And Ntlantla, you also had a question. My apologies. Sorry. Please go, Ntlantla.
Afternoon, ma'am.
Good afternoon, Ntlantla.
Ma'am, I have a question, ma'am. In some
Of
cases for
course.
geometric, when we calculate the sum, I've noticed that in some instances, ma'am, the 1 and R are on the other side, like they switch sides, ma'am.
Yes, and Ntlantla, you're right. So there are two ways in which you can write the geometric sum formula. So either you can write it as r to the n minus 1, or over r minus 1, or you can switch the 1 and the r around. I have never bothered to teach both of those formulae. I have always just taught this one to my students, and it always works. Okay, so I don't know. I know they do that if R is positive or if R is negative, it makes absolutely no difference. The only thing that you've just got to be very careful of in Ntlantla is don't get it muddled up with the sum to infinity formula.
Okay.
Okay, so sum to infinity, there's only one way that you can write that. But the geometric sum of a series, you can write in two ways, but there's only one way to write sum to infinity. Okay, and that is 1 minus r.
Thank you, ma'am.
Okay, so just don't get confused between the two. Okay, yes, we're all getting the same answer there. Okay, lovely. Well done. So hopefully we've cleared up a few misconceptions. Let's go on and do something that is a little bit more difficult now. All right. So I want us to have a look at this example over here. Here they want us to calculate the value of m. Okay. Does m, as it stands, represent the number of terms in this series? Does m represent the number of terms in this series? No, no, it does not. Okay, so if we wanted to know the number of terms in this series, we could calculate the number of terms by taking the number at the top, which is m, minusing the number at the bottom plus 1. So actually there are m minus 1 number of terms in this particular pattern. Okay, everybody. Hope you know where that comes from. Okay, the other thing, what does this bit mean that I'm busy drawing a purple circle around? Why are they now telling us that it is equal to 24 and 1 over 5? Yes, Amahle, what does that mean?
Good evening, ma'am.
Good evening, Amahle.
The 24 1 and 1/5 is the sum of the
Good.
sigma.
Well done. It is 2. Okay, so it is the sum of the series. Okay, absolutely. So it represents Sn. Okay, so Sn in this case is 24 and 1 over 5. We can write it as 24 and 1 over 5. We could also write it as an improper fraction. If we wrote it as an improper fraction, it would end up being 121 over 5. Or if you wanted to, you could also write that as a decimal. Okay, so you could also write it as 24,2. Okay, no one's going to mind, but that is the sum of the terms. That is Sn. Okay, can we work out what A is? Yes. Can we work out what D or R is? We don't know if we've got a D or an R. Let's go and sub in. Okay, so I want you guys to sub in. I want you to tell me whether it's a D or an R and what is the value of that D or R. Okay, I'm going to let you do this bit on your own. No, Lorraine. That would be old questions that you are doing. You won't see anything in the NSC papers that are out of more than 9 marks, out of more than 7, just one question on its own. All right, that's very, very rare. In the older papers, yes, there used to be things out of 9 marks, but I promise you, you're not going to see something like that now. 7 will be the most. Okay. All right, so you guys are working out what A is, and then you're going to tell me if there's a D or an R and what that D or R is equal to. Okay, Nhlanhla?
And those that are having load shedding, please do not worry. I also have load shedding, so if it does kick you out and in, we are recording. So you're allowed to rewatch it again by tomorrow. This time it should be uploaded on the Watobe's website. Okay, so
Sure.
you're allowed to come and watch again.
What are you guys working out the value of A to be? Good. I'm getting the same thing. Okay. Nhlanhla, you're like flying ahead here. Well done. I agree.
Nhlanhla,
That's
you're fine.
correct. So you got M to be 48, Nhlanhla. We still need to catch up with you. Let's see. Okay, Nhlanhla, let's give you this to keep you busy. Let's see if you can do. You see B in the corner here, Nhlanhla? And that'll at least keep you busy while the rest of us are doing this question. Yes. Okay, and the value of R? I hope you guys are getting 3. Good. Well done, everybody. Okay, so now we've got the number of terms in terms of M. We've got the SN, we've got A, we've got R. So now we can sub into our SN formula. Remember, here it is up here. Let's just drag it down so we can all see that on the screen as we sub it. So SN represents or is, and I'm just going to write it as 24,2. That's SN equals A. A is 1/5. R in this case is 3. Let's use square brackets here. R is 3. We can either write M minus 1 or we can write M. It doesn't matter. Okay, and then sort it out afterwards. The choice is yours, how you want to do this. Sorry, that would have to be N like that, or I could write M minus 1. So here I can either write N or I can write M minus 1. The choice is yours. Okay, I'm just going to leave it as N for now and then carry on. So minus 1 over R minus 1. So that would be 3 minus 1 like so. Okay, so now what we want to do is we want to isolate 3 to the n. Okay, so this is the bit that's a little bit tough mathematically. I know you guys have been through this before in class with your teachers at school, but let's just go through this again. Okay, so the first thing that you want to do, remember, you want to isolate 3 to the n, or we can write it as 3 to the m minus 1. Choice is ours. The first thing that we want to do is cross multiply. Now, in the denominator here, this is 2. 3 minus 1 is 2. I'm going to cross multiply 24.2 with 2. This is going to give us 48,4 is equal to 1/5 to 3n minus 1 like so. I've cross multiplied.
I see it.
Is everybody seeing that? You happy with that? I've cross multiplied the 2 at the bottom with the 24,2. Now I need to divide both sides by 1/5. So leave that 48.4 on your calculator and divide it by 1/5. Do you get 242?
Wait, ma'am.
Okay, I'm waiting. All right, so what if you divide 48.4 by 1 over 5, you should get 242. This is going to leave you on the right-hand side with 3 to the n minus 1. Now you need to transpose the minus 1. Okay, so you're going to take it over to the other side and it's going to become a plus. So that's going to give us 243 equals 3 to the n. And now, there you go. Yes, lovely, Sisipo. You can also multiply both sides by 5. Absolutely. Okay, you can divide 48.4 by 1 over 5, or you can multiply by 5. Probably even easier for you. Lovely. Well done. And now when you get to this stage, you want to make the bases the same. If you've done financial maths and you know how to use logs, then that's okay. For a lot of us, we haven't learned how to use logs yet. So the idea here, I'm just going to stick to the method that you've always done in grade 10 and grade 11 for now until we do financial maths, is make the bases the same. It's called equating the bases, and it's very easy. If you do not know how to write 243 with base 3, get 243 on your calculator, and then you press the Shift Fact button. Okay, so 243, Shift Fact, and it gives you, do you know what I mean when I say Shift Fact matrix? Also known as POP. Yes, 3 to the 5. Yes, lovely. Okay, now you must show that step. Okay, you've got to write 3 to the 5 equals 3 to the n. That's one of the steps you have to show, and then you can conclude that n is equal to 5. Very nice. Well done, everybody. Okay. All right, so how are we feeling? Are we feeling good about this? Lebogang?
Oh, ma'am.
Mm, but
Ma'am,
we're
can
not
I
finished
ask?
yet. Mm.
Oh, okay, ma'am. I want to ask something, but since we're not done, ma'am, I wanted to ask that wouldn't the m equal to 4 because you do 5?
Absolutely. So now we know what n is. Remember, n is m minus 1. Do you remember that? Remember, the number of terms n is m minus 1. The number at the top minus the number at the bottom minus 1. So just be careful there, because if 5 is equal to m minus 1, then m will be equal to 6 and not 4. Okay, so m is equal to 4. M is equal to 6.
Oh, thank you, ma'am.
Okay. Okay, so no, Gugu, did you understand? You following me now? Because remember, when you're transposing that 1, you're going to add 1 to both sides. Okay, n represents the number of terms. The number of terms for this pattern is m minus 1. So if m minus 1 equals 5, m would be equal to 6. Okay, I think you've got it now. Okay, so we just needed to finish that bit off. If you want to matrix, you can work, instead of working with n here, you could make this m minus 1 and write m minus 1, m minus 1, m minus 1, m minus 1. And can you see when you get to this stage over here, you'd still say m minus 1. That would be your equating your exponents would be equal to 5. You'd still get m was equal to 6. Okay, so it's up to you. You can either sub in, can either work with n and then go and do what I did over here at the end, or if you work with your exponent m minus 1 equals 5, you'd still get m equals 6. Does that make sense to everybody? Is everyone clear on that? Are we feeling good? So Sipho, go for it. Good.
Ma'am, can you hear me?
Yes, I can hear you well.
Okay, thank you. Hello, ma'am.
Hello,
I just want to
Sipho.
ask,
Of course.
will there ever be a time whereby you can't, like in this type of question, whereby you
Mhm.
can't make the bases the same for your
No, it will always be a case of being able to make the bases the same. And if you can't make the bases the same, it means you've gone wrong somewhere. So either
so
what you
you've never
subbed
been
in,
forced to like
you
use
always,
logs?
absolutely, always, 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 you'll be able to make the bases the same in this type of question, always.
Okay, thank you.
Okay, so you can use logs. Have you done financial maths at school, Sisipo? Not
Yes,
yet.
not
Oh, you have?
not this. I
Not
know
this year
we
in
haven't
matric.
done it this year, but
Okay,
we
all
did
right.
work with logs when we were doing exponents in
Okay. All right. So when I say logs, you know what I'm talking about. So,
yeah.
so yes, you will always be able to use logs as well if you want to. But for these sorts of questions, yes, you will always be able to make the bases the same. So if you're working with it and you are not, and the bases are not the same, it means you've gone wrong somewhere and you need to go back and see if you can find your mistake. Okay. All right. No problem. Okay. So yes, everybody, can you please show me C? I certainly can do.
While you're doing that, is it advisable for me to run the poll or should we wait a little?
I just want to show this to, there's the answer for B. So you can just mark that in Tlantla. Oh no, hang on. Which one was it? 1B. Oh, that was it. Okay, and then you said C in Tlantla. Oh, there it is. That's the one that you were doing. So you should have got n equals 35 in Tlantla. Yes. Oh, good. You did get that. All right. So the reason I'm now down here, if the rest of you I know are a little bit confused, remember I gave Nhlanhla this question over here, this question B, right? So he was just asking me for the answer to that. Okay. So what I'm going to do, because it's nearly time for us to run the poll, this question over here was also work out the value of M. So the rest of you can do this for homework. All right. If you want to, you can take a screenshot of all of this and then you can check that you got it correct. Okay. So you should get that n equals 35. Okay. So I don't know, or you can come back to the video and come and watch it again to get the answer, but just see that you can work backwards with this question as well. So that can be obviously not for Nhlanhla, but for the rest of you, you can go back and go and work on that one. Okay, so remember when you are working out the number of terms in a pattern, remember your n value, the number of terms, it always has to be a positive counting number. Okay, so it can't be negative, it can't be a fraction, it can't be a negative fraction. So yeah, go away and try this one as well.